Good day, my name is Timothy Adekunle. I'm here to start from where I stopped in my previous video, where I discussed about the proving of binomial distribution theory with practical example and Gaussian distribution with practical example. Today, I want to show us how to prove discrete uniform distribution and negative binomial distribution. Discrete uniform distribution. The probability distribution function of discrete uniform distribution is given as this. Expected value of discrete uniform distribution. Expected value of x equal to summation of x ranging from 1 to n x probability distribution function of discrete uniform distribution, which is this. Equation 2, we put the probability function of discrete uniform distribution into the equation, which is 1 over n. In this equation, we factorize 1 over n out of the equation, and we have summation of x ranges from 1 to n x. So we expand the summation of x ranges from 1 to n as 1 plus 2 plus 3 plus ... plus n. And this 1 plus 2 plus 3 plus ... plus n can be expanded as this. And if we look at the expansion of 1 plus 2 plus 3 plus ... plus n, we will see that we say, let's write 1 plus 2 plus 3 plus ... plus into the bracket n minus 2 plus into the bracket n minus 1 plus n. Write the reverse order of the equation above. That is, write the reverse, that is, write 1 plus 2 plus 3 plus ... plus n plus into the bracket n minus 2 close bracket plus into the bracket n minus 1 close bracket plus n. Write the reverse of it, which is n plus into the bracket n minus 1 plus into the bracket n minus 2 plus ... plus 3 plus 2 plus 1. Add both equations together, that is equation, the first one and the second one. When we add these two together, we have into bracket n plus 1 plus into bracket n plus 1 plus into bracket n plus 1 and so on like that. And that's the reason why when we see that all is n plus 1, now write n into bracket n plus 1. That is to say, n outside represents the nth time of n plus 1 and into the bracket n plus 1. And if we look at this equation very well, that is, we had two equations together to get n into bracket n plus 1. That's the reason why we divide it by 2. And that is where we get this equation 1 into the bracket 1 over n multiplied by into the bracket n plus 1 divided by 2. When we multiply it together, we have n into bracket n plus 1 all over 2n. And n cancel n. So therefore, our expected value equal to n plus 1 all over 2. That's the expected value of discrete uniform distribution. Variance of discrete uniform distribution. We have variance of x equal to expected value of into the bracket x square minus into the bracket expected value of x all raised power 2. So consider expected value x raised to the power 2. We have, which is equal to summation of x ranges from 1 to n s squared 1 over n, which is the PDF of discrete uniform distribution. We factorize 1 over n out, and we have summation of x ranging from 1 to n s squared. We have into the bracket 1 over n multiplied by, we expand the summation of x squared, which gives us to bracket x squared plus 2, 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared. We have to expand the into the bracket 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared. We obtain n into bracket n plus 1. Open another bracket 2n plus 1. Everything divided by 6. That's what we are going to obtain. So in the next equation we have, by multiplying 1 over n with the expansion of this, we have n into bracket n plus 1 to bracket 2n plus 1 divided by 6n, and n cancel n. We have expected value of x squared to be equal to n plus 1 into brackets 2n plus 1, everything divided by 6. So variance, now variance of x equal to, substitute the value of x, expected value of x squared minus expected value of x, everything raised by 2, to the equation of variance. We have n into the bracket n plus 1, close bracket, open another bracket 2n plus 1, everything divided by 6, minus, open the bracket n plus 1 divided by 2 all square. And when we expand that of n plus 1 divided by 2 all square, we have the equation 2, which is n plus 1, close the bracket, open another bracket 2n plus 1 divided by 6, minus n plus 1, close bracket, open bracket, n plus 1 divided by 2 square. By opening the bracket up, we have 2n square plus n plus 2n plus 1 divided by 6 for the first one, and for the second one minus n square plus 2n plus 1 divided by 4. We now find the LCM of both 6 and 4, which is 12. Say 6 in 12, we have 2. Now use 2 to multiply 2n squared plus 3n plus 1. We have 4n squared plus 6n plus 2. And 4 in 12, we have 3. Now use that 3 to multiply n squared plus 2n plus 1. And all the negative we have there is this negative. So we have negative 3n squared plus 6n minus 3. So 4n squared minus 3n squared, we have n squared, plus 6n minus 6n cancel each other, plus 2 minus 3 equals minus 1. So we have n squared minus 1 divided by 12. Our variance of x of discrete uniform distribution equal to n squared minus 1 divided by 12. Example of discrete uniform distribution. What is the expected value, variance, standard deviation of discrete uniform distribution of rolling one die? Solution. Let random variable s represent the outcome of the die. Therefore, our s equal to 1, 2, 3, 4, 5, 6, because a die has 6 sides and our n equal to 6. So expected value of x now equal to n plus 1 divided by 2 according to the proving. Now equal to where our n is equal to 6. So therefore we now have 6 plus 1 divided by 2. 6 plus 1 equal to 7 divided by 2. So therefore our expected value equal to 3.5. The average of the outcomes should be midway between 3 and 4. Variance of x now equal to n squared minus 1 divided by 12. And our n equal to 6. So therefore we now have 6 squared minus 1 divided by 12. And 6 squared equal to 36 minus 1 divided by 12. We now have 35 divided by 12. Variance of x now give us 2.9167. So standard deviation is the square root of variance of x. And our variance of x of discrete uniform distribution is 2.9167. 2.9167. And square root of 2.9167 equal to 1.7078, which is our standard deviation. Negative binomial. Negative binomial distribution. Negative binomial distribution has two forms of probability distribution function, and they are: first one is called to P into bracket s equal to x slash r, P equal to combination x plus r minus 1 combination x multiplied by p raised to power r into the bracket 1 minus p raised to power s, where s ranges from 0 to infinity, and p is 0 less than or equal to p less than or equal to 1, 0 otherwise. And the second one is p the bracket variable y equal to y slash r, p equal to y minus 1 combination r minus 1 p raised to power r to bracket 1 minus p raised to power y minus r, where x equal to r, r plus 1, dot 0 otherwise. But the second distribution can be obtained from the first one by putting y equal to x plus r. Proving of expected value of negative binomial. We have summation s ranges from 0 to infinity, x probability distribution function of negative binomial, which is equal to summation of x ranges from 0 to infinity, x combination p r is bracket 1 minus p raised by x, which is probability distribution of negative binomial. When we look at that of summation x ranges from 0, if we put a 0 in our equation 2, everything will be 0. So therefore, we need to start from 1. That's the reason why we have s ranging from 1 to infinity in that third equation. So expanding the combination form in equation 3, we have equation 4, which is s ranging from 1 to infinity, x into the bracket s plus r minus 1 close the bracket factorial divided by x factorial into the bracket r plus x minus 1 minus x close bracket factorial multiplied by r raised to power r p raised to power r into the bracket 1 minus p raised to power s. Note, in expanding the x factorial, this is this, and each of these one are this. In equation 4, we see that in the numerator plus x cancel negative x. That's the reason why we have equation 5. Ask summation s ranges from 1 to infinity, x into the bracket r plus x minus 1 close the bracket factorial divided by s factorial into the bracket r minus 1 close bracket factorial p raised to power r into bracket 1 minus p raised to power x. And if we look at this place, we say that r minus 1 close bracket factorial equal to r factorial divided by r. So therefore we substitute that into the equation 6. And we substitute x factorial to be equal to x into bracket x minus 1 into bracket factorial into equation 6 also. And equation 7, we just rewrite the r factorial divided by r. In equation 8, we factorize r and s divided by x out of the equation. So s cancel x, we have the next equation, which is this equation. And if we look at what we have there, in the second to the last equation, we can write it in combination form as this. Now we want to make the last equation, this equation, to be like the first probability distribution function of negative binomial. Now say that let y equal to x minus 1, which infers that x equal to y plus 1, and b equal to r plus 1, which means that r equal to b minus 1. Now say that r plus x minus 1 equal to b minus 1 plus y plus 1 minus 1. So r plus x minus 1 there now equal to b plus y minus 1. And since we know that y equal to x minus 1 and x equal to 1, now say that y equal to 1 on the value of x minus 1 there. So y equal to 0. So by substituting b and y into the equation, we have this equation. And this equation, we can see that we split out the p raised to power b minus 1 is 2. That is to say, we now have p raised to power b and p raised to power negative 1. Also, we have in the bracket 1 minus p raised to power y, the bracket 1 minus p raised to power 1. We factorize r p raised to power negative 1 in the bracket 1 minus p raised to power 1 out of the equation. And the remaining equation is a probability density function of negative binomial. And anytime we have summation of probability density function of any distribution, that will be 1. So that is where we get that one. And we now say that our expected value of negative binomial by proving now equal to r into bracket 1 minus p divided by p. Variance of negative binomial. And we know that our variance of x equal to expected value of x squared minus the bracket s into bracket expected value of x everything square. And we know that we can expand our expected value of x squared as expected value of x into bracket s minus 1 plus expected value of x. So therefore our variance now equal to expected value of x into bracket s minus 1 plus expected value of x minus into bracket expected value of x everything square, by considering expected value of x the bracket x minus 1, which will be this equation. It will be this equation. And if we look at the ranges of x, we switch from s ranges from 0 to infinity to s ranges from 2 to infinity, because if f is 1, all the equation will be vanished. That's the reason why we switch. That's the reason why we start from s ranges from 2 to infinity. And when we are talking about x into bracket x minus 1 combination r plus x minus 1 combination x, we can rewrite it as equal to x in the bracket x minus 1 into the bracket r plus x minus 1 factorial divided by r minus 1 factorial s factorial. And by expand this equation, we have this. So that's how we get all this place. So after that, now say let's y equal to x minus 2, which implies that x equal to y minus 2, and b equal to r plus 2, which implies that r equal to b minus 2. So therefore r plus x minus 1 equal to b minus 2 plus y plus 2 minus 1. Therefore our r plus x minus 1 equal to b plus y minus 1. So we now substitute for y, b, and r plus x minus 1 in this equation. So and we have r into bracket r plus 1 summation y ranges from 0 to infinity p plus y minus 1 combination y p raised to power b minus 2 into bracket 1 minus b raised to power y minus 2. So by expanding this equation, we have this equation, and we know that summation y ranges from 0 to infinity b plus y minus 1 combination y p raised to power b into bracket 1 minus p raised to power y, probability distribution function of negative binomial. So therefore this one now equal to 1. Now have r into bracket r plus 1 into bracket 1 minus b raised to power 2 divided by p square times 1. Our expected value of x into bracket x minus 1 equal to r into bracket r plus 1 close bracket open another bracket 1 minus p close bracket square divided by p square. So therefore our variance by substituting for expected value of s into bracket s minus 1 plus expected value of x minus expected value of x all square, by substituting for them we have this equation. Now factorize r into bracket 1 minus p divided by p out of the equation because it's common to all of the term. So we have r into bracket 1 minus p divided by open bracket r plus 1 close bracket 1 minus p close the bracket divided by p plus 1 minus r into bracket 1 minus p divided by p. So by open all the brackets up, we have this equation. And by the calculation, we have into the bracket 1 over p. By multiplying this together, we see that our variance of negative binomial distribution is equal to r into bracket 1 minus p divided by p square. Thank you for watching. Please don't forget to subscribe to my channel. Thank you so much. I really appreciate it.